So now we will have your presentations, and after that, we ask everyone to leave the room with all your stuff so that we can clean this and set up for the awarding. Outside, you find foosball tables, food, drinks, so you have plenty of stuff to do. For the presentations, you have 3.5 minutes. After that, the screen will turn black, and there is a timer there, just to remind you. So there are like 3 teams. So as soon as the team is done, the next one on the line should like go there. So we always have a queue of 2. Okay? We will start with the data track and then coding track. We still miss. Okay. Yeah, that's missing.
Jesper, are you ready with the timing? Okay.
Okay, are we ready?
Yeah.
So
3, 2. No, wait. I will give you the start.
Yeah.
So 3, 2, 1, go.
So thank you, everybody. We are 60, and we are really happy to present as first one in our data track analysis. So we inspected and analyzed public bike users' behavior to exploit useful knowledge that could be used to internal logistic and marketing purposes. And how do we do this? We tried to visualize the data first, and in order to visualize it, we built our R script that is showing on our left. Wow, why? This is not showing, guys.
We'll give you additional time.
Yeah, I think so, but how to make it work? Yeah, now you can see
The
something.
time has been
finally.
paused for a while.
Yeah, thank you very much. So what we can see here, from our left screen, you can see all the stations and where the bikes are coming from, while on the right screen, you can see where the bikes are going to. And the circle is measuring how many bikes are going to and coming from, while the color is indicating the relative importance of that station. So we have already an example here. In the fall semester at 9, users are going from all over the city where to Uzi, as you can see here, and they are not, their average trip is like just 1 kilometer, while, for example, we can go to the summer and see where people are going in the night. And where do you think they are going? Yes, they are going to drink something to Lugano Marittima or to the city center. And as I previously said, these data are very useful to predict where people are going to go and to track useful conclusions. But my colleague will talk about this in a second. So please, Hal.
Thank you. So based on our findings at hand, we want to explore the correlation, the different linkages between public bike and other data sets. So we merge with bus data and also the number of commuters at each time. So we're basically looking at 2 aspects. The first aspect is about the substitution effect between the buses and public bikes, meaning that if you want to go to work, you can choose to ride a bike or to take a bus. And basically, we find that when there are more buses, they will lower the ratio of Swisscom commuters choosing public bike, which is very reasonable, right? And the second aspect we want to discuss is about the user profile analysis. Among all those commuters, we have 2 profiles. One, maybe some students that are going to university for study, and the other profile may be some employees going to the city center for working. And during the summer breaks, we find that even though the students are leaving their universities, there should be more bikes available in the city. We still don't see an increase in the ratio in the commuters riding a bike, meaning that they don't actually care or they don't want to change their plan. So basically, this is the key findings, the figures we find out in the substitution effect. we see that from 9 p.m. to the midnight, where there are few buses, we have 10% of the commuters who are actually choosing public bike. And this is very significant because they drive like 20% or over the total variations by the commuters of the usage of public bike. And the second thing is that we see that employers don't want to ride public bike more often. So we recommend employees to encourage them
Time
to
is
do
over.
more during the summer holiday. Thank you.
Quando parto? Appena si vede. Sì.
3, 2, 1, go.
So everybody, we did a fantastic fork, and we worked on this dashboard, me and Camillo, and it is about LAC marketing dashboard. So the motivation is to provide a tools and a dashboard for the people that work in the marketing department at LAC to understand better their products and to promote them at best through especially digital marketing campaigns like Instagram and Facebook. So we combine the data of like shops that we have of Lugano City. We have a lot of transaction for different type of products of LAC and weather information that we get from Swiss media, basically. So the first thing we went through, we wanted to understand if there is some type of products that LAC sells that is more affine to a certain type of season. In this case, we can show, for example, the autumn examples, and we see there are some type of products like biglietti per vendita list, which is theater tickets and music tickets that are really like strongly correlated to autumn. Basically, this means, so the upper they are, the more correlated they are to autumn. It means that almost more than 60% of this ticket from the music and the theater are basically only sold in autumn. And the more you are on the right, it means the more famous is the product. So in this case, for the music and the theater, this is the top second most sold product, and most of them are sold in autumn. And this is very interesting because then the consumer, so which is not actually the user of the dashboard, it's going to be the marketing people in the LAC, can click on this point on the dashboard and understand when this product is actually most bought by the people in autumn. So in this case, we see that a lot of transactions are actually coming in Wednesday, for example, between 19 and 20, at the same times on Sunday and 15. So I understand that maybe this should be the time where you should advertise actually this kind of products during the week in autumn. At the same time, you're going to be able to visualize the trend in autumns of this type of ticket. This is always for the music and the theater. You see that there is a peak in week 38, 39, and week 40. That's because there is the starting of the season, of the theater season and the music season at the LAC. Obviously, you have a peak of tickets that are sold there in that case. But then also matching the weather data to this kind of shop data, we saw actually an interesting correlation that most of the LAC ticket for a lot of different type of products actually sold when the weather is bad. So we tried to understand if there was a correlation between bad weather and different types of shops that are more selling in Lugano, and we came out with this rain affinity dashboard. So the upper you go, the stronger the rain correlation, so you're more likely to buy a ticket on LAC when it's raining, and the rider you go is the more famous is the product. And you see that LAC in this case, not only in the year 2018 was the shop that sold most tickets, let's say, or most products anyway, it's actually very likely that you want to go to the LAC when it's raining compared to when it's actually sunny. And this is very interesting because maybe you could run campaign specifically when the weather is bad on digital campaigns like marketing and Facebook and Instagram. You can specifically say, I want to sell this kind of products when it's raining and not when it's sunny, or actually run campaigns like free museum when it's raining, for example, or change the price of the tickets. For example, it's like cheaper when it's sunny and more expensive when it's raining. So maybe you encourage people to go to the museum when it's sunny, or at the same time you make more money when it's raining, basically. So that's it. That was the strategy. So this is just a...
Okay, thank you. So now is the round.
Remember
of
to line up for the next teams.
Are you ready?
Yeah.
Okay. Okay. 3. Just wait for the slides. Okay.
All right.
3, 2, 1, go.
Hi everyone. We are the Deep Fried Data team. I'm Manav and my friend Rama. So we are looking at the data in a wholesome manner, and we are trying to create a potential index of for the city of Lugano. We are going to look at this potential of the city from different perspectives. One is what is the potential of the city for the business investors, for real estate investors, and for students and for tourism. We are also going to look at this, the data available about the city of Lugano from a sustainability point of view, and taking inspiration from Mercer's livability index, we will also try to figure out how livable the city of Lugano is. So we look at the demography data that is shared with us, and we see this trend here that the number of males between the age 20 to 30 has consistently been rising for the past 10 years. However, for the number of females, it was rising till 2015, and then we can see a sharp decline, which is a concern for the city. And also we can see that if we divide the population into young, old, and adult, then the adult population has already plateaued, and the old population is increasing over time. This provides the city council to concert their policy efforts into development of the city and try to figure out where to put its resources in. Then we look at the sustainability index of the city of Lugano, and we compare we look at the profile of the pollution for the city of Lugano. We figured it out that the city of Lugano is on an average more polluted than other Swiss cities. Then we figure out some anomalies in this data, as you can see here and here, on days where the pollution in the environment was significantly higher. Then we look at the data across on the whole year, and we look at the profile of an average day, and we see that during office peak hours, the pollution is the highest. And we also figured out some correlation between, small positive correlation between the commutation and the pollution. Then we look at the bus delay data, and we figure out that there are some outliers, some anomalies where the buses are in general delayed across all lines. This can inform the public policy to invest efforts in these lines. Rest my friend will explain.
So Lugano has invested into charging stations for electric vehicles, and most of the vehicles, most of the charging is in a few stations. Like this is in million kilowatt hours, so you can see like there's a huge difference, and particularly this one is the one near the university. And interestingly enough, the average tariff of power rates, and the parking fees are pretty similar. Like this seems to suggest that parking is a huge concern in Lugano. And also from the parking data, we figured out that in more than 1,000 occasions out of 27,000.
Okay, time is over. Thanks a lot for your presentation. I'm kindly asking the Putin's Friends team to come on the stage, and the FODA team to be prepared for the next.
Okay.
You have HDMI, it's okay.
Yes, HDMI. Okay.
Are you ready? It's okay? Good. Jesper, 3, 2, 1, go.
Okay. Our project is named Traffic Jam Measuring Index. It is a measuring indicator to prevent traffic jams for a better lifestyle. Here in Lugano, there is a problem, traffic. So to address this problem, we designed this Traffic Jam Index to measure it, quantify it, and actually be able to act on it. It's a mix among intuition, experience, and data provided for the hackathon, and just a little bit of math. So we design in this index, and we build it merging geographical information by our trends, and measure, monitor, and manage in order with the people in mind. Our analysis, then, after building this index, we made an analysis merging these 7 datasets. So starting, for example, from the bus line information to number of trips and nationalities of the trips, going, for example, through pollution and so on, having some results.
All right, so this is the first way to visualize our resulting index. So as you can see, if I plot it, the average value by hour of the day, you can see that we have a peak during rush hour, as expected, and a lower peak in the morning. Then, of course, you can go deeper, and you can plot this measure on a map. So as you can see, at 10 in the morning, there is just a little problem close to the highway, but then throughout the day, the situation evolves, and when you get to rush hour, as you can see, you have big problems in the city center and in Paradiso area, and also in other parts of the city. All right, so next thing we want to do is we want to address this issue about cross-border workers. So basically, Italian people coming from Italy to work in Lugano. And many people living here claim that traffic problems are mainly generated by these so-called frontalieri. So to shed light on this issue, actually we merged together our traffic index with data from Swisscom measuring the number of people arriving in Lugano. And we broke those down by nationality. And as you can see, when the number of people coming from Italy increases by 1 standard deviation, actually the level of traffic decreases on average. And the other way around for Swiss people. So when we have more Swiss people coming to Lugano from other parts of Switzerland, actually the level of traffic decreases. And this stays true even if we control for other factors that most likely have an effect on traffic, and actually they have, because as you can see, the R-squared goes up to 20%. So we control for temperature, for precipitation levels, the number of people in hotels, and the usage or parking places. So I'm not claiming that this is causal evidence, of course, but this is correlation evidence, and at least I can say this is not consistent with the story telling that traffic problems are mainly generated by Italians coming to Lugano to work here. All right, so to conclude, we will provide also another application, another usage case for our data. And the rest of our team will talk about this in the coding track. So they will use our index as a fuel for an application which provides a gamification of the bike sharing utilities. All right, so that's it. Thank you for your attention.
Great, congratulations to be on the time. So I kindly invite for the team to be on stage, and Lugano Circle to be prepared for the next one.
Cercate di stare un pochino vicino al microfono, altrimenti non si sente tantissimo. Perfetto, ok. Ditemi voi quando siete pronti. 3, 2, 1, che compaiono le slide. Lo dico io di far partire. Voi mi dite quando siete pronti. Prima aspettiamo le slide che stanno arrivando.
Ok.
Prova, fai così. Ecco, guarda, aspetta. Ok, aspetta. Ok. Pronto?
Perfetto. Sì.
Okay, let's go. 3, 2, 1, go.
Okay, so good evening. This is our team. My name is Gerardo. And we used, for this project, we used IBM Cloud and IBM Watson for data analysis. So we've discovered that the city of Lugano have got a serious problem with the ozone pollution. And we confirmed the correlation between the pollution of ozone, environmental temperature, and traffic circulation. We've also discovered that the most dangerous month for citizens of Lugano is July. So what is ozone? Ozone is created by the jam, the smog, and the sunlight. We've confirmed that the pollution of ozone is directly correlated by the traffic jams. In particular, in weekends, we've got less less cars, so less ozone. We've also known that the limits are 120, and we can exceed this limit at maximum 5 times a year. But Lugano exceeds this limit 50% of the days during a year. We've also reached the peak of 270. So that's why, we've also confirmed that the ozone pollution is correlated to the perceived temperature, and we discovered that the summer is, of course, the most dangerous, the most dangerous season, and particularly the month of July, as we can see from the peaks. Is there something we can do? And of course, there is. And introducing Green July. Green July is an idea. We wanted to change. We wanted to change the most dangerous month into the most ecological one, stimulating the use of green transport, like giving some discounts to citizens, and increase awareness, like installing some banners with live information about the pollution of the city, or implementing temporary eco-incentives, or ultra-low emission zones, and alternate license plates. But the most important things are the green events during this month, like the green themed hackathons, recycling and life hacking courses, green themed shows, giving discounts for those who come in bus at these events, and establish green Fridays with sales, and the opposite of the Black Fridays. So that's it.
Thanks a lot. So next team is Lugano Circle, right? And then Acatoni, the next one, which will be the last one of the data analysis track. Okay. So 3, 2, 1, go.
So imagine you want to enhance the network system of Lugano, the public transport. You're not going to do this by observing basically the city. You need to imagine what would happen if we have a new bus stop, what would happen if we have a new bike stop. No, we want to see how this will affect the current system that we have. So with the detail what we have created basically is a simulator of the public transport system that we have in Lugano that matches all the statistics, with respect with the TPL data, the public bus data, about the availability of bikes, about the availability of buses, about buses arriving before, buses arriving later. It matches all of this. And now that we have this very, very complex simulator, we can let people interact with this, For instance, a person, first trying to go from the house to the university would start maybe walking directly, It would be something like 40 minutes here from Sorengo to the university UC. But as it iterates and it interacts more with the network, it discovers better and better paths. Basically, it discovers that it can use the buses, it can combine with bicycles, and at one point, basically, it finds what will be the shortest possible path from their house to the university. And always imagine that we have many of these people, coming from these different places. We have people going from Breganzona, people coming from Massanio, people closer to the university. We would expect that these persons will go maybe walking and using bikes, and people that come more from the mountains will use more the public transport in the sense of the buses. So here what we can see is the optimal route that each one of these persons could take. For instance, a person is coming from Breganzona would take the number 3. Then it will try to go to the station. It will try then to go to Lugano Centro, combine with the 5, and go to the university. At this point, the policymaker is happy in the sense of saying, okay, I have a simulation of my city. And now I want to imagine what will happen. How can we enhance this? How can we actually make people, for instance, from Breganzona arrive faster to to the university. So we can see, for instance, that there is no like bike stop like near to Breganzona. No, it's in Sorrengo, and actually because of the altitude, it's very, very far apart. So what the policymaker can do is to say, well, what if I create like a bike station that is closer? What will happen? And with our system that simulates all the possibilities, it discovers that basically like a person can take the bike and arrive in 20 minutes versus the 40 minutes that was before only using like the public transport in the sense of the buses. And so this is the idea. So we have the simulator, and now we can basically start trying things like adding new bus lines and adding new bike stops, and trying to see how can we like enhance the transport. What is the most optimal way of simplifying the life of Breganzona, of Mazzagno, and pretty much everybody in the city. Well, thank you very much for your attention.
Great, thanks a lot. So I invite the Acatoni team to be on the stage as the last team of the data analysis track, sorry. I'm tired.
As are we.
Ok, yeah, I guess. Voi avete USB-C. Lo collegate e aspettate un attimo, ci mette un po' di collegato così. E state vicino al microfono.
Ok, ho visto che sembra.
Sei pronto? Ti do
Sì.
il countdown, posto?
Dammi un
Dimmi tu,
secondo.
dimmi
Sì,
tu.
va bene. Vai.
Posto?
Sì.
Okay. 3, 2, 1, go.
So, I'm here to represent the Hackathon team, and we believe that data analysis is made for insights. So that's what we wanted to get out of this data. So what we did was build models that do delay prediction on the public transport from the data that we were given, specifically from public transport and meteorological data, because we believe that those two correlate really well in describing the traffic of the city without an actual description of the traffic, which we did not have. So we built, as I said, two models. The first one is particularly useful for outside players because it only requires easily accessible data, which was that is what I mentioned, so meteorological and public transport data, and is able to reach minute level precision. Of course, to do that, we need a deep neural networks, so that is what we built. While the second model is more specifically useful for TPL, Trasporti Pubblici Luganesi, because it uses recent route history, which is a data that really only them could have. It is based on a clustering of the bus stops, and it lends itself to extremely precise predictions with the precision of some seconds. And we reach that with a recurrent neural network, which performs very well, of course, with time series. So the first model, okay, so one possible use for the first model would be to reduce waiting times across Lugano, because it lets people choose alternative routes when they know that maybe the next day there will be particularly heavy traffic for their particularly heavy delay for the route, or bike sharing services can use that to advertise more aggressively when there is a high delay. And the same goes for Uber and Lyft. The second model improves on the state of the art of delay prediction, which is really simple delay propagation. So if the last stop had 5-minute delay, we propagate and we say that the next one will have 5-minute delays. We improve on that by using, as I said, a recurrent neural network which looks at time series. So as I mentioned before, we used clustering for the bus stops to build our the second model, which was the one based on the recurrent neural network, and that data lends itself very well to a cross traffic analysis, because with the first model we can predict what the delay will be for each bus stop. If we cross that data with the clustering of the bus stops, which is made based on geographical data, so for example, stops that are close together will likely be in the same cluster, we can perform a basic traffic analysis. Because of course, if there is a high traffic across all the bus stops in the same cluster, that means that in that geographical area, there is likely to be a lot of traffic. So we kind of built a traffic, a metric for the traffic based on the data that we were provided that did not actually have that. And that is clearly very useful and it has a lot of use cases.
Okay. Thanks a lot. So now we will start with the coding track. That means we have 15 presentations to go. And there are 2 teams that will present also in this track. So the first team of the coding track is Bike Me There. And I invite the team C. Manda to be prepared to be the next.
Mirroring, arrangement. Okay. So, vabbè, qua. Good.
Sei pronto? E do il countdown.
Allora sì, possiamo anche partire.
Okay. 3, 2, 1, go.
So, taking care of the environment is the greatest challenge of our generation. Lately, we have been talking a lot about what we can do as individuals to take care of our planet. One of the solutions proposed here in Lugano is bike sharing. In the last few years, the city has installed more than 20 bike sharing stations that people can use to move around. And they work wonders, but they're no silver bullet. Rest assured that if you plan to leave this place using one of these amazing bikes later today, there is the distinct possibility that you won't find one. Many bike sharing stations in Lugano, even the ones that offer many bikes, are left utterly empty at times, especially when people need them the most, that is early in the morning or late after working time. So tomorrow morning, you'll get to Lugano by train, you'll look for a bike, and you will be left wondering where all the bikes have gone. And well, not surprisingly, the answer is they are all here at the university. So this is why we made Bike Me There, an application for sustainable mobility in Lugano, which encourages users to use public bikes, leaving them where they are needed the most. Our application will give you directions to move throughout the city using bikes, and it will always suggest you the shortest path that will get you to your destination, but also an alternative, more sustainable path that is still short, but will allow you to leave your bike at a station where we know that bikes are needed. So users are encouraged to take the alternative path so that they earn rewards, possibly in the form of a discount on their public bike subscription plan. So building upon the bike transportation data that has been made available to us for the hackathon, we have built a model that can predict the stations that will have fewer bikes available, taking into account both the day of the week and the time of your trip. Our interface automatically updates every hour and leverages this model to suggest you where you could leave your bike so that other users can find the bike and use it. So Bike Me There is both sustainable for the environment and economically convenient for the company that provides the bike. Having the vehicles available where needed means that we can avoid relocating the bikes to high-demand stations continuously throughout the day. And this way, the company can cut on bike relocation costs and also reduce their impact, of course, on traffic and pollution. More bikes available, of course, also mean happier customers and thus less canceled subscriptions. Bike Me There is tailored on Lugano, where we plan to launch a pilot. And from there, we plan to extend the app to other cities in Switzerland that have a bike sharing system in place. We also plan to integrate other sustainable transformation means into the app, for instance, buses or, I don't know, electric scooters. So as I said, taking care of the environment is the greatest challenge of our generation. Bike sharing is a great step forward, and with Bike Me There, we can make it even better for everybody. So you're very welcome to come by our desk if you want to play with our application later. Thank you very much.
Thank you very much. So. USB-C.
Oh. Ah, ok. Questo è l'HDMI. Tu cos'hai HDMI? No, USB-C. No, HDMI, ok. Dovrebbe essere di parte. No, basta. E tu sei Siemens, giusto?
Sì.
Ok. No, aspetta, tu dammi il via che io
Un attimo, ok.
So team is Siemens, and I ask also the next team to be ready, which is Mrs. B. Okay, faccio il countdown. Okay, 3, 2, 1, go.
Welcome everybody to the presentation of Tucano, l'applicazione tu con Lugano. We are Simanda, it's me, Albert Weiser, with Boris Bezzola, Daniela Gianora, Mattia Della Mora e Nicolo Pancera. So, what is this app about? Well, it's an app to rank the districts of the city of Lugano based on a set of user preferences. Who is it for? Well, people looking for a place to live in Lugano that suits their choices. Perhaps someone who wants more information of the districts, like the city itself for development purposes, public transportation services, or real estate agencies who wants to place perhaps their advertising. So we put in a bit of work, and this is what we came up with. We have our preferences. Let's say I'm a student and I want to live here in the city. I like density of population. I think it's a very important factor because I want to have a contact with lots of people. Yes, I like the structure of the city, so swimming pool, museums, and so on. I want them around. TPR stations, but maybe I don't care too much about public bike. And you can see the ranking updates, and now I'm presented with my choices. Perhaps Molino Nuovo? Okay, what's this place like? And I have my description of the district, population, so on, facilities, some nice photos. What's the city center like? And so on, you can see my ranking is done. Well, we couldn't exactly create the app completely as we wanted because the data were kind of limited, but there are still some features that we would like to implement in the data. Perhaps the type of district. I want a residential one, an industrial district, and so on. Perhaps the number of shops nearby. I like convenience, I like them to be close. What's the traffic like? What's the pollution like? Or perhaps more data on the bus, or transportation, or train station nearby. So, there is space for improvement if there is data. This is Tucano. Thank you very much.
Thank you very much. Now is the round of Mrs. B team, and I kindly ask Putin's friends to be ready for the next.
May I have the cable for the Mac?
Yep.
USB-C.
Yep.
USB-C is okay if we leave it here?
Yeah.
Stay down here.
Do you prefer here?
Yeah.
Okay. So, once again, the only thing is that the microphone is here.
Okay, that's fine.
So my press, I think you have to plug it. Okay, so I think you should stay here.
Yeah.
You can let me know when you're ready. Just wait, and it will count the slides. Then you tell me when you're ready. And
We're ready right now.
Okay. Be very close to the microphone. No, not so.
Okay. Right here.
Okay.
Yeah, perfect. Yeah, thanks a lot for everything.
Okay.
Okay, so
3,
let's get started.
2, 1, go.
All right, so our project is to classify trash correctly. It's a big problem in Lugano. We got a little data that we can show you. So this is on the train station. You can see on the cartone, which is paper, there's plastic bags. In aluminum, there's aluminum. But in PET, there's aluminum, which is misclassified. And then if we go into rifiuti, which is all trash, once again, there's paper. So out of 4 bins, 3 are wrong. So that's 75%. What we basically did is we built a deep neural network that classifies this type of trash and that opens the trash accordingly. So we used the camera, DNN, and then we classified into these 5 classes. And for the batteries, which are not included in the trash can, they get into, they get redirected to the closest eco-center using an algorithm finding the closest eco-center.
Okay, so without much ado, let's just show us very small demo of what we do because there's limited time. So here's the demo, and the demo sort of works in such a way that we allow the trash can to be opened only if the classification is correct. Otherwise, it's not opened, so it doesn't go into that trash can. So whatever goes in, we are sure, okay, if it's aluminum, it's going to be aluminum for sure. So you can see that the bottles are classified correctly, and we can do a classified trash, and the correct sort of can opens up. Now, what if it's not one of these categories? If it's something like a battery, which have to be redirected to a eco center, not a trash can. So in that case, it wouldn't classify anything. It would give you a location. You scan this QR code, you get the nearest you scan this QR code and you get this nearest location for where you have to go to dispose of this. Now,
can show the aluminum when we get time.
Yeah, sure. Yeah, so that's aluminum. Now, the idea is that we not only want to do this, we also want to figure out where to place these trash bins. Currently, the one that exists is only in the SBB station, but we have different zones in our in Lugano, right? So we were given the demographics data, which tells us how many people are living in a particular area. So what we did was we tried to map this to the number of bins required in that area. So obviously, if the number of people in an area are more, the trash produced in that area is more. So we tried to do this. We could probably try to make this better by by real-time data, but given that we are given population, so more population, more trash, and that is how we model this. So quarterly, we could try and plan to place these bins in an appropriate location and figure out how many bins we need to place in these locations. So as our judges had suggested that these could be really well scaled to places like training people how to figure out which is the right class, because people misclassify between PET and something that is plastic. This could be scaled to industries so that we ask them to use this in their supply chain so that whatever comes in, they are sure that, okay, they can use it in their supply chain for sure. So there's no human intervention here. It's classified automatically. You just place it, it's done.
Okay, thank you. Next team, Putin's friends, and I kindly ask Fenkat team to be ready on the stage for the next one.
I can put you?
Sì, sì.
Okay.
Big. HDMI? Yes. Okay. Prendi questo. E another set. Okay. Okay. Just wait for a second. A few seconds. Let me know when you're ready. I will.
Okay.
Do the countdown. Just be a little bit closer.
Hello, hello.
Just wait.
Okay. Should I? Okay.
No, just wait.
All right, tested.
Okay, just a few seconds.
I'm ready. I'm ready.
Okay.
A little bit.
3, 2, 1, go.
Good afternoon, everyone. We are from Pudding's Friends Group. But first things first, I want to talk how was the start of this hackathon. With my group, we will start to see about the data about buses, weather, pollution, a lot of things. And we saw that a problem here in Lugano is the traffic jam, even more between 6 p.m. and 8 p.m. Not we start to think if it was just a thing from the database that the hackathon sent to us. So we went out of the hackathon and started to talk about the workers here nearby the hackathon. And we saw that it is a thing that really exists. That there was one that was talking about this like for 1 hour. So about this problem, we developed Bike for Life. It's a mobile app for iOS and Android that integrates companies of bike renting with other companies that offer services, for example, restaurants, markets, or even more companies of train transportation. So our idea is to be the Move It of Google Maps. Move It does the same thing of Google Maps, offers the same thing, but offers a best user experience for the users. You want to make the users can rent bikes as well, but with best user experience. We think about putting gamification inside the application, so every user that takes the bike will have the distance traveled counted, and this will become points for them. And with these points, you can pass levels, earn achievements, reach missions, and passing levels will earn coins that can be exchanged with discounts in this market, restaurants, or even more in these train tickets. A lot of people here that participate in the Lugano Economic, they are from Italy, so they come by Italy by car. Why don't they use the train to come here and use the bike here so they help for the transportation? So here is a demo for our application. You can enter there nearby there is a bike that you can rent. You select the bike, there's a multiplication score that depends on the day, depends on the hour, location. So with this multiplication score multiplied by your travel, you can earn experience points. With these coins that you earn, you can exchange with discounts coupons. You can compare yourself with your neighborhoods in the ranking. You see your own data. So our next steps make it wider, not only bikes, but as well with walking, with bus, or not even only the people that work and go by study, but as well with other people or even blind people. So this is our team. I like so much to work with them. Thank you for your attention.
Thank you very much. So next team is Fenkat, and I ask the team Slipknot found exception to be ready for the next one. Sure.
So go for? Yeah, I am ready. I am ready.
Closer, but not so much. Thank you.
Okay, 3, 2, 1, go.
So hello, everyone. We are team Fencat, and in the last 48 hours, we spent time trying to come up with both an app, but also a business model that would benefit both the end user and the municipality of Lugano and or the public transportation system. So here is our application. If we reload the page, we can see that, as expected, it finds our location and also the nearest bus stops and public bike stations. If we select a bus stop in just a few seconds, you will see that it shows us the next departures from that station. And also we computed the average delay for that line at that time, for that day of the week. And yeah, that's it. So this is the easy part. Now for the added value, we can now simulate being anywhere in the city just for the demo. And when we get close to a bus stop, you can see that a button lights up on the bottom. And we can say, okay, I am now going to take the bus here. So I click it, and my trip starts. And so now I will just move around the city. And in another stop, I can say, okay, now I finished my trip. What this allows us to do is compute the kilometers that a user makes with a public transportation system, and then also gamifying it. And so we have a leaderboard with the user and the total kilometers of that month that they made using public transportation. So where is this added value? So with this system, the municipality can know exactly how much usage of each public transportation was made during the month. And also, we could provide incentives for users on the one side, so the user has a benefit, but on the other side, the city would know exactly what lines from what stop to which other stop the public transportation system is more loaded or has more usage, as to improve the system. Okay. So for the technology, we deployed everything on a server behind an Nginx server, which provides encryption and basic authentication as to protect the data. The front end was coded using React. We used Python for the APIs. We also deployed our own map provider, and Elasticsearch for the data that was provided to us. And sure, we can improve this with better tracking and more transportation types. That's it. Thank you very much.
Thank you. Next team is Sleep Not Found Exception, and I kindly ask the bees to be the next.
Is it mirror red? It is mirror red already.
Ready? Yes. 3, 2, 1, go.
Hello everyone, we are Team Sleep Not Found Exception. It's me, Alex, and Gustavo, Federico, and Valerie. Our application is called Replay, and it's a data visualization tool for historical data. We can replay the data, and potentially could also be real time if we would get real time data. So we chose to show data for September because that's the month where we had the most data. The possible use case would be to show this dashboard to the population so that they can see how many kilometers were traveled with the bike and how much CO2 was saved by doing so. We show this information on the sidebar. So the features of the applications are that we can play and pause the live visualization, and we can even speed up the visualization. So we show also on the sidebar how many times faster it's going. So in this case, it's 64 times. We can also jump to any point in time during the visualization, during the month. So now we are at the 12th of September. What we also show is the meteo data and the pollution data, again for the specific moment in time. Right now what you're seeing is being updated around every half an hour of the visualized data. So the data sets that we use to show this are bikes, public bike, TPL for the buses, meteo, and pollution data. So the blue dots that you see on the map are the bikes, whereas the red dots that follow the lines are the buses. What else? Okay, so the kilometers data is the complete total aggregation of all the kilometers traveled by bike, whereas the CO2 is a calculation based on estimations by the European Swiss administration. Yes. Okay. What we were hoping to see is whether during a rain moment, where the precipitation is more than 0 millimeters, so not in this moment, there would be a reduction in the use of public bikes, which would be expected, and whether the pollution would increase. However, the pollution is probably also influenced by the precipitation itself, and we don't exactly know how the measurements have been done. The data, so the actual paths followed by the buses and the bikes are computed by us, because what we had for both data sets were just points in time and positions at where the bike or bus was in that moment. So so the bus stations and the delivery stations for the vehicles. So we were not able, we didn't have actual data for the travel, and we had to compute this ourselves based on bus lines and well, the streets of Lugano. So thank you very much.
Thank you. Next team is the bees, and I kindly ask the Fantastic Four to be the next.
Just wait a few seconds. Sure, sure. Can you tell me when you're ready? And I will
Once the image is up.
Just be a little bit closer.
Yeah.
Okay. 3, 2, 1, go.
Hello together, we are the Bees with Marco, Yuri, and myself. So, a bit of background information. In Switzerland, there are more than 5,000 electric cars, with a trend to go higher and higher. So there will be about 3 times that much in 2021. This also means there should be more stations to charge the cars. And an average charge takes roughly 1.6 hours, because electric car drivers experience time differently. If they have 1 or 2 more minutes to charge, doesn't matter to them. On average, that's 10,000 minutes a year that people wait while their car charge. So let's imagine Lisa. She's a 28-year-old young and sportive woman. She commutes to Lugano every day by car. The thing is, she doesn't know where to charge a car. She has to find a free one every time, and that's a problem. And once she found the free charging station, she doesn't know what to do, because there's a lot of time that she just hangs around and doesn't do anything. So we came up with a solution. This is the map of Lugano, as you can see. And we took the data that you provided of the charging stations that can be sent to our app and will be visualized. Green are the ones that are free, and red is obviously taken or occupied. Furthermore, there is a dashboard that Lisa could use. Let's say she will use this station here to the right. She finds it, she plugs in the car, and now she wants to do something cool, or she's hungry. Also, she's a bit lazy, so she doesn't want to walk too far. Let's say give her 300 meters of distance, and she wants to have a drink. Immediately, she can find some bars that will be recommended by an API, a business break, or another Irish pub. She can also calculate the distances by either walking, since her car is charging, or once the car is fully charged, she can calculate it by driving. This is so far the prototype. What we can do more is predict, based on data, how long the occupied charging station will charge until it's free. So let's say it is occupied right now, but within 5 minutes it will be free. So it's worth to go in there. Also, you want to reserve your stations, otherwise you drive there and then it's already taken. we have some open APIs that you can feed information in to display on the map, as I showed you. But we can integrate even more possible activities or other things that you can do. Streaming data, for example, is another option. And we have to sell it, because for Lugano it's interesting to support maybe local businesses that might not be known to tourists or commuters, so we can promote them via this platform. That's pretty much it. Thank you.
Thank you. Next team is the Fantastic Four. Can I ask the Guinea Pigs to be ready for the next?
Aspetta un attimo che devo vedere dove si è messo il display. Ok. Un attimo. And, dov'è il mouse? Ok. Così.
Okay, 3, 2, 1, go.
Good afternoon, everyone. We're Riccardo and Lorenzo. We're here to present Luganud, Compete for a Better City. Luganud is an Android application whose goal is to use gamification and to make the citizen aware of healthy activities for the city and themselves. To do that, we built a competition among them where you, the citizen, and your neighborhood will clean together the top of a leaderboard. But who are actually your neighborhood? Well, as you may know, Lugano is divided in districts. So, for example, me and Lorenzo are from Molino Nuovo, so we should band together to earn ADI points, which are the points that we use to reach the top of the leaderboard. There are three kinds of them: ecological, cultural, and sport, that can be earned by doing different activities around the city, like taking the bike instead of the car, will make you earn some ecological points. Now Lorenzo will show us a live demo of the application and how to use the ADI banks, which are one of those points of interest that can be found around the city.
So, of course, we cannot just trust the user to input every activity he does. So what we build is this honey bank. And basically, it could be put anywhere. For example, let's imagine this is in the library of Lugano. And after you rent a book, you simply put your phone close to it, sorry, and it will register a culture point, as you see. So now I have increased my culture points from 22 to 23. You can see again from 23 to 24. These points are not given actually to me, but as we said, to my district, so in my case, Molino Nuovo. We can go to the leaderboard to see the score of the current district, to see which is on top. At the end of a certain period of time, we can decide that the top district, for example, will get some discount regarding the city of Lugano. For example, I'm going to museum or other services. This is great because actually you're giving discounts to people who actually use your services. So you are encouraging the growth of the economy. Another great opportunity for this app is actually after the app is used, because whoever is behind, so the Comune of Lugano, for example, could see all the activities that are done in a single district and analyze them to build specific tasks to improve the living experience of the people of that district. For example, improving public transportation and so on. Another important thing is how the points are given. Right now you see, if I scan, I get 1 culture point. This is calculated based on the actual activity that you perform. Let me give you an example. If you take the bus on Monday, you will get, for example, 1 point, because everyone takes the bus on Monday for going to work or school and so on. However, we saw on the data that you gave us that on weekend, bikes and buses are usually less used. So what we could do is give more points for the situation to encourage the usage of less frequently used activities. And that's it for us. Thank you.
Thank you very much. Next team, Guinea Pigs. and I ask not optional team to be ready for the next. Yes.
Non è la prima volta. Allora, avrei preferito farne a meno, di verità, però. Allora, qui. Speriamo che funzioni. Sì, va bene. Ok, aspetta che... Funziona? No, non ho preso l'enter, vabbè. Non so come fare. Vabbè, fa niente, faccio senza. Faccio senza, sì, 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 sì.
Okay. 3, 2, 1, go.
So, good afternoon, everyone. We're the guinea pigs, and today we're here to introduce you to Citywise. So, we wanted to tackle a problem that I think everyone has faced in their lives. So, you decide to move to a new city. Let's say you decide to move to Lugano. So, first of all, welcome. Second of all, what? So, what do? You need to find a house. You need to find, for example, a gym if you want. And to do so, it's not easy. You need to talk to people. You need to understand what part of the city is the best and so on. So maybe you start with Google. You start Googling some information. Or you go on Google Maps and you try to get some information out of it. But most of the times, Google Maps looks like this. So it's very business-centered. There's not that much information about houses, about what is available. So we decided to develop something that could help people moving to a new city. In this case, we used Lugano. So we had 3 goals in mind. It had to be simple, it had to be extensible, and it had to be customizable. That was the goal of the project. So what we came up with is this. So on the left side of the screen, you have the dataset togglers, essentially. You decide what dataset to see. The interface is very simple, so you simply have a map of Lugano, and then you have that blue dot, which is you, so we're able to track you. And how we have achieved this, so how do we show these layers and so on, is through the actual use of layers. So at the bottom, we have the map itself, and then for each of the data sets, we created a layer. So for this hackathon, we decided to focus on 3 main data sets: the buses, the Città di Lugano, so the parking spots, and the bikes. But as I said at the beginning, the goal was to make it as extensible as possible. So this is very easy to add another layer. To do so, we use Elasticsearch with Spring Boot as a middleware and Vue.js in front using Cesium. And this is essentially what it looks like. So once you get into the interface, you decide, for example, to see the bus stations. So you have an overview. If we click on one of them, for example, the one behind the university, it shows you the route, and it shows you how late on average it is. We have a breakdown of the delays for each hour of the day and actual day of the week, so you can understand better if it's on the weekends or during the week. We give you, once you click on a station that has multiple lines going through it, we show the route, the whole route, so you know where to go or where to find other activities. We also show you how late on average the lines are for this station. We also have this system which allows you to pick a time, so let's say 5 o'clock in this example, and it tells you which lines to avoid, so you don't get stuck in traffic or you get late to your appointment. We also show you the bike stations, so you can better choose where to look for a house or where to look for activities, depending on whether you have a car or not, or you take the bus or you take the bike. We also have the parking spots, the parking lots. In this case, this is the average for all of them. So as you can see, you have dips during the day for the availability. So you know that during the day you should avoid the car, but you should avoid it anyways. And then you have a breakdown for each and every one of the different parking lots by time. So thank you very much.
Thank you, guys. Next team is not optional, and I ask the team JG to be the next.
Sounds about good. Mi era errato, perfetto. Sì? Ok.
3, 2, 1, go.
Hello everyone, I'm Alessandro Romanelli and I worked these 2 days with Cristian Buratti, Pasquale Polverino and Diego Carlino. What I want to bring to the table today is a solution to the modern problems that we do face every day here in Lugano. As you all know, viability as well as smog are a great deal of concern for all of us. So when we gathered to brainstorm some ideas on how to approach these problems, what we came up with was a solution to reinvent the navigation system. So what are we actually bringing to the table? We don't want to make you get to the destination necessarily faster, but we are bringing a new navigation experience. So what do I mean by that? By that I mean that we want navigation not only to be fast, we want it to be environmentally sustainable, tailorable and customizable to your needs, convenient, but also enjoyable. So not only always the same trip from A to B and B to A. So before I give you a short demo, let's just talk about which technology we used. And those were the database technology provided by Elasticsearch, the Node.js for the backend, and the React.js from the front end. On a smaller note, we also used Python to digest the amount of data that was gently offered to us. We also wanted to thank Publibike, TPL, the municipality of Lugano, and AIL to bring us the data that we use to produce our app. So this is a visualization of the data that we were able to gather. And let's cut to the real deal, and let's show you what the app is like. Whoop. Okay, so what we really want to achieve with this app is that it may look like Google app, but what we want to do is that I want to start from somewhere, say Via Madonetta, and I want to go to Corso Pestalozzi. There we go. And what actually happens is that these 2 points are sent to our server, and it's efficiently calculated and computed several different ways, not only the fastest from A to B via car, but also when it loads. Okay, there we go. There are shown several different options that we can choose from. We can choose to go from A to B by just walking. We can do that by just walking to a public bike station, taking a bike, placing it to another station, and walking the rest of the way. We can use the public transportation system of TPL, or we can use an electric car, park it in a recharging station, and walk the rest of the way. Also, we were able to achieve.
Okay. Thank you. Next team is US JG, and I kindly ask the VI Write and Quit team to be the next, alias ESC WQ.
Qua il... Sì, però la parola lì. Stai un po' più vicino al microfono. Certo, certo. Era più così, se parliamo adesso non viene preso dentro. Dimmi tu quando sei pronto. Sono pronto. Vado? Sì. Aspetta. Mi date il countdown? Ok.
Okay, 3, 2, 1, go.
Hello everyone, I am Jason Aldi here with Simone Masiero and Gregory Wulliman and Umakantia Kandja, and together we are Lugano Alive. If you are someone who lives here in Lugano and you want to see how well the city of Lugano over time has been able to serve your needs when moving around, we believe we have the right application for you.
Hello. So how does our application solve the mobility problem and this kind of problem? Basically, we mapped two kind of data: parking lots, and bus lines onto geographically and in time. So if we start our visualization, we can see that things are starting getting red and green, and the more green a parking lot gets, the higher the occupancy, and the more red a parking lot gets, higher occupancy. The more red a bus line gets, the higher is the delay. So from this, we also can infer the context of the situation in time by seeing how much is the percentage of commuters and non-commuters, and from which countries they come. So basically, what can we say when we look at this? We can basically see if the parking system and the layout of Lugano is capable of meeting the requirements of the citizens. So basically, these two parkings are meant to be used by commuters so that they can go here, park in this zone, and then go to the center of Lugano by these trucks, this bus line. And we can see that this is happening, and Lugano are handling this problem well. But there are other parts and other parking which does not really work well and in this way. And from here, you can address this problem. We only have data for specific times, like we have the parkings only from mid-June to mid-September, but it's easy to extend this approach and basically insert new data for anything which can be mapped in time and in space, like public bike and other kinds of data. Also, we can extend this project with cumulative graph analysis so that we can see the heartbeat of the city and how well it behaves handling the mobility problem. So to conclude, I introduce again Jason Naldi.
The idea is when you are looking at this application, the greener the city looks, the better it is able to serve you. The redder it looks, the worse it is able to serve you. So we are Lugano Alive. Thank you for your attention.
Thank you, guys. Next team is ESC-WQ. And I kindly ask the Warriors Pink to be the next.
USB-C?
Sì, ma sì, USB-C dovrebbe andare, vediamo se gli piace.
Ho fatto HDMI però.
Ah, sì, sì, c'è.
Va benissimo, benissimo, come volete.
C'è già.
Mi dici quando siete pronti, stai un po' vicino al microfono, non ti dico
Qua è scomparso, aspetta.
Togli quello bianco.
No, non siamo in presentazione adesso. Present. We can make it. Start the presentation. Ok. No intro. Your connection. Ok.
Mi dici quando sei pronto?
Sì, 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 sì.
Gestisci tu la...
Ma gestisci soltanto devi schiacciare.
Sì, sì. Dimmi tu quando sei pronto. Ok. Posto? Andiamo. Sì.
3, 2, 1, go.
Hello everyone, I'm Max, and our product is about a plan of route. We know that every good trip starts from a good route plan. I mean, our product is about mobility, is about a better mobility, a greener mobility, and maybe even a pleasureful mobility. Our product is a kind of enabling layer that allow you, it's not just an app, it's not just a kind of program or website or something like that, but it's something more than a platform that enable you to give service to your citizen, tourist, and so on. And Okay, for the comparison for other services.
As you can see behind my back, a lot of traditional routing system, a lot of traditional navigational system lacks a lot of intelligence, a lot of knowledge about the territory and about the services that you can provide. To give you some context, for example, try to ask Google Maps what it knows about the pedestrian zone in Lugano. Our idea is to present a new kind of service that allows you to select different ways of transportation and compare them with a traditional route that you can drive by car, for example, and allow you to choose for a better experience, something greener and something healthier, maybe.
Okay, our layers so enable in the next step we'll enable a single point of payment for each chunk of services during your trip. For example, for citizens, maybe they need to rent a car or maybe take a bike, or maybe for the tourists are better than sightseeing itinerary or something like that. This is our architecture.
We've currently implemented our product and is available as a public demo. And it is kind of simple. We have used a lot of the data that you provided us initially. For example, we use the geographical location of our parking sites and public bikes sharing sites. And we use them to find what is the nearest parking to your destination and what is the nearest bike sharing site to your destination to allow us to build a route that will enable you to choose the bike over the car inside the city, even if you are commuting from outside the city. All this data is stored inside Elasticsearch that provides us with the main data store for the system. We use Akka HTTP to provide for the REST API for the front end that is implemented using Angular to provide for a smooth integration with Cordova should we choose to implement a mobile application.
Okay. So, well, I'm coming for the difficult part, which is a demo. Okay. So, this is a public address. Okay. And if we try, for example, to look for the street from Massagno, I don't know, Massagno to Lugano, we can see that our system find a solution. The red one is only by car, and the other one is using different services.
Thank you, guys. Next team is Warriors Pink Unicorns. I forgot the unicorn before, right? To say unicorn. And I kindly ask the Molly Coders team to be the next. We have 3 teams to go, then it's over.
When you're ready, tell him so we can just go.
Okay.
It's okay. Just be not too far away from the microphone, but it could, like this is fine.
Okay, thank you.
Go with the camera.
3, 2, 1, go.
Hello, everyone. After 2 amazing but sleepless nights, let me present the problem we focused on and our solution to this problem. Well, the problem, our cities are attacked by pollution, and we have to fight back. How? Well, we need to motivate users or the citizens to use ecological ways of transport. And how to do that? Well, our solution is a game which helps, or let's say, in which our users can fight the pollution monsters by logging their ecological ways of transport. So going by a bike, or taking a walk, or going by a bus. Why do people should do that? Well, it's a game, so it should be fun. Then it's a possibility to contribute to improve the local healthy environment. It's also possible to get some rewards based on your score and a level in a month. It's also possible to compete with your friends or family, and also to see some personal statistics, like how many kilometers did I drive in a month. So what we want to reduce is the pollution, the noise, and the traffic. These three are the main things we need to do. And what we delivered, we actually prepared a demo of an Android application and then an Angular web. So let's hit the first demo. So this is the actual app, but it's somehow small now because of the resolution. So probably we move to the web app, in which we can see our user, Sidak, and the monster that he has to fight. So let's say he took a bike today from Morcote to Melide and submit. Now we can see that the monster got some damage. Our user got some experience, and for a short period of time we could see that we saved some fuel and the distance of the journey. But it doesn't have to be only the bike to take, so let's say we walk. So we walk from the park at the lake, let's say to the university here. So we choose 2 points, and we submit our walk, and we walk 800 meters, and we made further damage to the monster, and we gain some XP. Like this, we can continue to increase our level. So what we actually use to build our stack, it's Elastic and where we store the data. Then we have the fully working backend based on Python and fast API, and then we have 2 front ends for the user to use. We also gather some analytics data, which Andrea will talk more about in a few seconds.
Yeah, we basically, all the data from the user, we keep it in the Elasticsearch, and with Keybank we can actually get in real time, for example, the starting points, the endpoints, the average fuel they use, and the average distance they actually do.
Thank you. Three, two, one, go.
Good afternoon, everybody. We are 2 queens and 4 pawns, and today we are here to present our prediction map. Our project is here to solve the problem of transportation in Lugano, because today the current situation is not really good. Because now, if somebody from outside Lugano wants to go to the city center, he has a destination, he has real-time information about buses and parking occupancy, but he doesn't have any information about the future. So it is really bad, because if he takes the bus and the bus will be late, he will waste time, and even more if he will take the car and there are no parking free, he will waste time and will also increase the traffic, because he will probably stay around until he finds something. And to solve this problem, we use the destination to make prediction in the future about the parking occupancy and buses lateness. With the historical data that we have, and then we give recommendation to the user based on the arrival time. And this recommendation will tell the user how to go there and where to go. And this is really good, because now a user can save time and can choose to go maybe to the city center now, or maybe try maybe in 2 hours or in 3 hours based on the recommendation. Now, Eva will show you a small demo.
So the user can input his starting position and his goal destination. He can put a tick on the stations, parkings, or bus stops, whatever he's interested in, and then he's gonna get this map where we basically have the arrival time, because we take the time of the day currently and we compute the distance and the occupancy rate, and based on the occupancy rate, we based on the rate, we give a green if it's less and yellow if it's medium, and red if it's occupied, or for the case of buses, if it's late. And now my colleague Olivier will tell some info on the stack.
So to be able to retrieve the closest point of interest to the user's destination, we use the GeoShape query feature of Elasticsearch. And as you see on this Kibana visualization, we loaded all points in different layers. So it's really easy to add more points of its interest, such as public bike stations, for example. Here are some of the technologies we used. So Elastic for the database, and we did the backend in Python using Flask, and the visualization with Express.js, and we use Pandas and Keras to do the machine learning prediction. Okay, that's it for us. Thank you for your attention.
Thank you. So we tried the second attempt with the Modicoder. And then this is the last presentation.
Sono un po' più... Prova. Okay.
3, 2, 1, go.
Hello everyone. Sorry, I apologize about the inconvenience. So to explain our work, we are going to provide an example. We are going to visit a city, and for example, the city of Lugano. We arrived there, we don't know what to do. Basically, we simply open Google Maps, and we want to identify some activities, some place to visit. But what if there is an app that can provide automatically an itinerate about some activities or some place to visit? So the idea of our work is this one. And this work is a Grand Tour. It can provide a set of activities automatically, so it doesn't provide only a suggestion for the place, but can provide experience for the user. How does it work? Simply, we take our phone, we simply ask the app what we want to do, and the app provides an itinerate for what we want to do. It takes the query, it's computed by Elasticsearch, and then a set of possible activities for our user is computed, and then Blackmagic. We implemented several algorithms to identify the best possible itinerate for our user. So at the end, we have a set of our itinerates, and we want simply to travel to do something in the city. An example of our app is this one. We have a set of input, a set of preference for the user. So we have what we want to do, the effort, the duration, and the budget for our user. Then we have the set of itinerate provided by our application. And then we have the map that can show the itinerate, the set of activities that we want to do during our permanence in the city. Our application is cross-platform, so we don't. It's not an app. It's not only an app, but it's accessible to the web. And then the data used for this application is public bike provided for this challenge, OpenStreetMap for a set of activities or location of interest, and then Lugano region for some hiking and walking activity. The technology used are this one, and thanks everyone for the attention, and I'm apologize again for the inconvenience.
Okay, thank you very much to all the team for your effort. Now the hackathon is over. The jury will meet until 5:30 more or less, and then we will have the award ceremony. And I would like to thank you, all of you, and give you a big applause on what you've done. And I wish you good luck. We'll meet you here again. You can bring your stuff outside because we need this room to be changed. And we will meet you here again at 5:30, more or less. See you later.